Alright, Paige, please take out your earpod. Thank you. That's very good. And that'll be on the recording now, so everyone will know that you were a terrible student and had your earpod in, okay? And they'll also know that you aren't broke and that they can't and you can't hear anybody. Right? That's what AirPod memes are about. Okay, so we'll have a median, okay? So in 5.3, we'll be talking about a couple different things. Today we'll just be talking about the median. So a median of a triangle, think kind of like a median of a road. That's also where the word median might be used, and you've heard it before probably, or perhaps you've heard it. It's going to be there. So it's somewhat similar to that idea, but only in one way, and then different in others. But I digress. A segment whose endpoints are a vertex of the triangle and the midpoint of the side opposite that vertex. So our angle bisectors and perpendicular bisectors, those could be points, rays, lines, planes. Our median can only be what? A segment. This one can only be a segment, okay? It can only be a segment. So our other ones that we've had so far, perpendicular bisectors and angle bisectors, could be all these different options. But this one, median, can only be a segment. And it goes from a vertex of the triangle. Recall the vertex is where the two sides of the angle meet. Triangle has three of them, kind of the points of the triangle. Goes from a vertex to the midpoint of the opposite side. Now there's only one side that's opposite this vertex, correct? Because is this side on the top left opposite that vertex? No, it's touching it. Is this side over here opposite the vertex? No, it's touching it. But this side down here is not touching it, it's opposite it. So it goes from this vertex straight to this midpoint. Is it perpendicular to this midpoint or to this same side? No, it doesn't have to be. It can be, doesn't have to be, okay? It's usually not. But it does go to that midpoint. That's an important concept for us right there. Now we're actually going to skip this constructing part. We're going to skip this constructing part. Okay, and you can draw through it. You can draw through it. We're going to skip the constructing part on that. That means we're probably going to skip this constructing part as well. Now the three medians, they do end up meeting. They do end up meeting somewhere. But I think the constructing part's a little less significant for us. Okay, I think the constructing part's a little less significant for us. It'll look something similar to like this. And they would have met around here. That was actually pretty good for being informal. And they would have met around there. It's always going to be inside the triangle. What we call, you didn't have to draw that. The three medians of a triangle are concurrent. Concurrent. What's concurrent mean, guys? Not congruent. They intersect all at one point. Concurrent are when three or more lines intersect at the same point. So the medians, segments can intersect as well, is where three or more segments are concurrent, three or more medians are congruent at a point called we call it the centroid. Centroid. Centriole, that's biology. There's centrioles, centromeres, centrosomes. So the three medians of a triangle are concurrent at a point called the centroid of the triangle. And we have the centroid theorem that goes along with it. The centroid theorem states that the centroid, where the three medians meet, and we know it's three medians meeting because it goes from a vertex to the midpoint of the opposite side. You know it's the midpoint because these dashes are here. So we know these are all midpoints. So P here will be our centroid. Centroid is located exactly 2/3 of the distance from each vertex to the midpoint of the opposite side. So each of these medians have their own length from each other. They're not necessarily the same length as each other, but each median is broken into a ratio by the centroid. So what we're saying here is if in a triangle, I kind of draw the same triangle off to the side, but only use one median from like A to X here. We're saying that from the centroid, the vertex to the centroid will be 2/3 of the whole thing. So if the whole entire thing, actually let me go over on this side for it. If the whole thing is, let's just call it some length, I'm going to call it W. The only reason I chose W there is because it's not a letter that's used anywhere else.
Okay.
So we don't confuse it. We could call it X, but we already have an X. So W, if that's the length of the entire median, vertex is the opposite midpoint, then this top part is going to be 2/3 of W. The vertex of the center is going to be 2/3 of W. So what does that mean the rest of this is? The 1/3 of W, the remaining 1/3 of W. I recommend drawing this kind of picture off to the side. I recommend drawing that picture. Once you draw that picture, we're actually going to be, and then write this one thing as well, and we're going to come back to it.
I did not draw
1/3, 2/3 rule. So write these things that I wrote on here, and then you can pack up. So I wrote this, and then this.